Okay, good morning, good afternoon, good evening. Hello and welcome, ladies and gentlemen. Welcome to yet another webinar from the AWS Discovery Day. So this is the second webinar that we have today. And this webinar, it's really cool, really interesting. So I'm glad so many of us decided to join. In this webinar, we will be talking about how to build a modern data strategy. So essentially, we'll be talking about how we can use data, all the data that we have available, data coming from all the different sources, how we can use all of this essential information to provide better products, better services to our customers. So essentially, how we can use data that we have to improve our business. So definitely stay tuned. This is going to be very interesting. This webinar is going to last about an hour and something, so don't worry. I'm not going to take up too much of your time, but hopefully it should be worth it. A little bit about me. My name is Tomas. I'm a big AWS geek. I've been working with AWS for over a decade now. Various clients, various industries, various projects. So should anybody wishes to stay in touch, I'm super happy to answer any questions and stay in touch with you even after this webinar is over. So the QR code, there's the link to my LinkedIn profile. Feel free to add me, send me any questions you might have. I'll be very happy to engage with any AWS relevant discussion. So that's a little bit about me, but this webinar, it's not about me. This webinar, it's about data. So let's face it, it's quite hard to stay relevant. Probably whatever business you are, I'm pretty sure you're facing a fierce competition coming from just about everywhere. I do have couple of very interesting articles here. Essentially, the first one is from Forbes, and the article it's about having access to more information. So just by adding 10% of the data, so 10% of information that you already have, just by making it accessible, the Fortune 1000 company can see $75 million increase in the net income. So just making 10% information available can make you significant income opportunities. Also, another quote from Richard Joyce, senior analyst at Forrester. In here, he was again surveying companies, Fortune 1000 companies, and he discovered that the companies can accomplish about 415% ROI, 48% reduced total cost of operation, again by using data, again by making data accessible, by making data-driven decisions. So I'm pretty sure we all agree that data is good, having access data is good, data offers us potential, but how do we actually make use of it, or what can we expect to get out of the data? So we've identified three areas where businesses realizes most of the benefit from modern data strategy. The first one, it's improvement in operational efficiency. Essentially, we can increase our agility, run things more efficiently, provide better customer experience, provide better products and services by moving to the cloud, by moving our data to the cloud, and by using our data. By using our data, we of course can make more informed decision. Essentially, if you make a decision based on guesses and estimates, etc., it's more of a lottery than a decision. To make a really informed decision, we need to access the information so we can have meaningful insights, by bringing all this information together, and we can draw some meaningful conclusion. All this information can also accelerate the innovation, can also unlock new opportunities for us, possibly new revenue streams, something that in the past was unthinkable. Now having access to all of these AI technologies, machine learning technologies, deep learning, etc., neural networks, we can go on and on. By accessing all of these technologies, the new discovered opportunities that didn't exist in the past are here now. The question is, if we're gonna use this opportunity, or if we're gonna, let our competitors get ahead. So, data-driven organization or data-driven organization look like these three parts. First one, data-driven organization realizes that data is an organizational asset. So we now have to think about data. We now have to consider data to be the organizational asset. So data should not be considered like a property or individual department, units, team being, hidden somewhere in some folders in like personal laptops, etc. All data should be put in a single place, and all data should be accessible throughout the whole organization. So whoever needs data can access the data whenever we need it. Obviously, saying about whoever needs can access it, etc. Of course, don't worry. We'll talk about security. We'll talk about governance. So only relevant people will have access to data. But whoever is authorized to access the data needs to have that level of access. Needs to be able to access it immediately. Because when we put data to work, when we use machine learning technologies, we can discover, we can use these technologies to make better decision, improve efficiency, drive our innovation even further. We can improve the operational efficiency, as we're talking about, provide better customer experience, perhaps come out with a new products and services that we didn't even think were possible before, and all of it it's here because we've simply used the information that we already have. So it's good, data is good. Let's all use the data. If we actually, get into it, if we start, figuring out how we might want to put everything in place, we're probably going to find a couple of challenges in the way. First of the challenge could be about size of the data. So imagine the information that you have, imagine the information that's continuously generated. It's being said that in the next 3 years, there'll be more data created than in a prior 30-year period. So essentially the speed of generating new data, there are all of these new IoT devices every single day, and the speed is exponential. So it's getting faster and faster. So we have more and more information. The biggest problem, probably from a company perspective, is that you're going to discover hundreds, maybe thousands of individual data silos. So data being stored in some server, in some databases, in some folder, maybe even like printed information, being stored in a box somewhere. So you've got all of these information in all of these different places. The problem is now, how do we actually, put all of this information in a single place? So how do we actually make all of this information accessible? Also, another challenge that you might come across is actually the technological challenge. I know I said that we have all of these amazing technologies out there. We've got artificial intelligence, machine learning, neural networks, etc., etc., etc. We've got all of these technologies out there. However, do we actually have enough skills and knowledge to be able to truly, utilize all of these technologies? So another challenge. And possibly the last challenge that I already mentioned, since we now have more information than ever, we now have a different system using different technologies, some of these AI technologies, which are potentially for us are very hard to grasp. Like, how does it work? How my information is handled? So the security, privacy, and compliance will obviously going to play the biggest role ever. So it's up to us, whatever data we have, whatever technology we're using, that we follow all of the applicable laws, all of the compliance standards. So we're not by utilizing additional technologies, having access to more data, we definitely cannot worsen our compliance posture. So essentially, there are two approaches that we can take. The approach number one is the survival approach. It's probably the lesson from the recent pandemic. Essentially, the survival approach is about cutting costs. So every year we want to cut some costs. Every year we want to save time. Every year, we want to maybe automate something, just make some minor improvement. This is, things that we have to do to simply survive in this competitive environment. Or there's the second way that we can also take. This is to thrive. So if we actually want to thrive, if we actually want to utilize all of this information, if we want to utilize all of these different technologies that are out there, we need to build a modern data strategy that will grow with us in the future. Essentially, we want to use information to modernize our infrastructure. We want to use all of this information to put data in work, invent new experiences, bring new product, bring new services. We want to use all of it that's available, to truly get the maximum benefit out of it as possible. So up to you to choose. Do you want to survive, or do you actually want to thrive in this competitive world? Obviously, if you're looking for areas where you could put data in work, I'm pretty sure if we did a little brainstorming in here, we could probably come up with hundreds and hundreds of different suggestions. So what we have in the slides are just some of the suggestions that AWS recognizes are maybe the most important ones, or maybe the first one for us to take a look at. The first category is the improved operations. Essentially making our internal processes better, our forecasting processes, financial forecasting, automation processes, optimization processes, supply chain optimization, fraud detection, anomaly detection. So all of the internal processes can definitely benefit by having a modern data strategy and by putting the data to work. Obviously, we have to think about our customers, so improved customer experience. That's something we should definitely focus on. Personalization is the big thing. We want to understand our customer as much as possible. I know in the past we had this kind of like wave of generation, these like generic website, like, customer who bought it also bought this. It was very, very generic. We find out it doesn't work. Every customer is individual. We need to truly understand customer. We need to personalize customer experience so the customer has the best possible time. Contact center intelligence, also a really big opportunity for us, especially if we as Amazon, running huge data centers with thousands of operators in it. Obviously, just making things a little bit better on the massive scale is going to present a significant advantage for us. Customer insight-driven product development. Obviously, we want to offer the products and services that our customers truly wishes. Maybe another possible use case we can take a look at is marketing optimization. So how do we improve our marketing? How do we improve targeting? How do we, again, this customer 360 experience? How do we better understand customer churn analysis, etc., etc. So how can we target, new customer for our products and services? Lastly, any applications that we might have, I'm pretty sure we will be able to find some areas how to make them better. So why don't we actually use data to discover these opportunities? So we have data for database application, dev operations, etc. So the use cases that you can see here on the slide, the use cases that we've talked about just now are absolutely not, the only use cases to use data. Just take a look at, just consider this as kind of like maybe like a couple of first places that you can take a look at while you're thinking about a modern data strategy in AWS. So why the things that we used in the past didn't work? Probably if you have, if you've been in business for a while, you have some IT landscape, you have some IT infrastructure, most likely you're gonna have, a whole bunch of databases, probably also some data warehouse solution as well. So data warehouses, that's something that was used in the past, traditional solution, just put, all the data in the databases, transform them using some ETL mechanisms into the data warehouses. And now we can use data warehouses we can use the data in the data warehouses for analytical use cases. So that's the approach that we had in the past. The problem with this approach, it was very hard. It was very expensive to run it, hard to implement. We had not up-to-date information. The transformation processes were pretty hard. The ETL mechanisms were pretty hard to do. Also, we typically had a whole bunch of different data silos. You can find some, you can find all of these data warehouses and database applications, throughout your whole company, throughout the different departments. So essentially, this approach didn't work. That's why customers are moving from this traditional approach, the data warehouse approach, into a data lake approach. Data lake approach could present major benefits over the traditional data warehousing approach. With the data lake, essentially we're going to take information assets, store the information in a cheapest storage there is out there, and now we can have various different analytical tools, analytical technologies, machine learning, AI. We can run anything that we want from the data on the data lake. So I've got data, I can store my data very quickly, I can store my data very cheaply, and I can run any analytics as I want. So this is how, in a nutshell, the data lake is going to help me over the, maybe more traditional data warehouse solutions. So when we look at a modern application is probably a cloud application, so it's the application that we develop in a cloud. A modern application quite commonly uses this microservices approach. Essentially, if you ever seen application in the past, if you ever seen the application code, it was miles long of, I don't know, Java code, Python code, whatever it might be. So essentially, we built a huge monolith, and we're slowly adding new features, changes, slowly redeveloping the big monolith. The modern application is not using this approach anymore. Essentially, the modern application is trying to break apart the individual pieces from this big monolith. So any business functionality that we had, we just take it apart from this monolith. We use purpose-built services, purpose-built data store. So whatever tools, whatever languages, whatever frameworks, whatever data store like databases are the best for that specific problem, not for the whole application, but for that specific business functionality. We have a full flexibility using that. So this is essentially the approaches that we're taking with modern application, microservices approach and purpose-built data store. We can see an example on this slide. We have an application, got some search functionality. We have a different data stores like key value data store, graph databases. We have relational databases. So essentially, it's kind of like a Lego. We're putting a lot of pieces together rather than having a huge monolith, like one huge piece. So a modern data strategy. How do we actually do that? We've talked a lot about, why it's good, why the current approaches might not work, but how do we actually get started? How do we actually do that? So essentially on the slide, we can see the components of the modern data strategy. So first one, the modern data strategy needs to work for any data at any scale. So the modern data strategy needs to allow us to store data that were previously in all of these silos, needs to allow us to store it in a central repository. In AWS, we're most likely will be using a service which is called S3. It's a simple storage service that we can use to store an unlimited number of objects. So, okay, whatever data I have, whatever format, from whatever silos that it used to live on, I'm going to take all of this information, I'm going to store it as is. So I'm not going to do any transformation at this stage. I'm going to store it in an original format as is in S3. S3 after I've stored, so I can store the information very quickly since I don't need to do any transformation. And I can also store it very cheaply since S3 is the cheapest storage service there is out there. After I have all of my data stored in S3, now I can run any analytics, I can do any machine learning, any AI, I can do absolutely anything since I have the data in the original format. So whatever format I need to transform, whatever modifications I need to make with my data, it's absolutely fine because I have the original format. So now I can do absolutely anything with my data, run any analytics, do absolutely anything that I want. The S3, as we said, will offers us the best price performance for the application. Not only S3, if we want to utilize some other purpose-built data services, maybe we still need a relational database. Maybe we need some of the non-relational databases like graph database, for storing relationships between the data, or even if we still need a data warehousing solution. With AWS, we actually have 17 purpose-built data store. So whatever our workload is, whatever the requirement we have, we can find the best service out there. We're actually doing all of that. We're doing the, storing most of the information in its original format in S3 because we need to allow, our customers, not our customers, we need to allow our data analysts, our machine learning specialists, we need to allow our employees to easily access the information so they can do whatever analytics they need to do. Also, another benefit of storing, all the information centrally in a single location would be a unified governance. So again, as you can imagine, if I have information spread apart in thousands of different databases, different data stores throughout different servers, computers, etc., doing a governance, it's going to be a little bit trickier. Enforcing governance, it's going to be a little bit tricky. Fortunately, if I have everything in a single place, now I can use AWS services to automatically discover, tag, catalog, and keep all of this information across all of the AWS services in sync. I can centrally define all of my governance, all of my policies, audit policies, etc. And I can also use AWS to enforce all of these different requirements that I have. So from one single place, one single service, I can enforce my governance. And last but not least, we need to stay modern. We need to be able to use, what's available in the market. So whatever technologies, AI technologies, ML technologies, I don't know, deep learning, etc., whatever technologies, tools, framework you want to use, you've got information, you've got accessible information. Now use the tools that you want to draw some insight from that info. So how can we do how can we do that in AWS? Essentially, building a modern data strategy on AWS will consist of the three parts. The first part is the unified part that will essentially offer us the best from both data lakes and purpose-built data stores. We've got a modernized part, which is about modernizing the infrastructure, perhaps using a cloud provider that will offer us the best suite of services out there. And the last part is the innovate part. So bringing new product services, new experiences by using the advanced technologies that are out there. So what we're going to do now, we're actually going to drill down into all of these three parts a little bit more. Let's start with the first one. Let's start with the modernization part. Obviously, as we said, the data is not going anywhere. The world of data is not slowing down. It's actually the other way around. It is accelerating. So customers, who are able to dig into this world, customers who are able to actually use the data to build amazing products and services, these customers will strive. So how do we do that? What customers are doing. If we want to get more from that, if we want to get more from our data, if we want to get more from the assets that we have, first of all, we need to break free from the legacy solution. So if we have a legacy solution that's not flexible, legacy solution that's very expensive, legacy solution might be any technologies, any database, any data warehouse technology that's preventing us from being able to operate even quickly, or we need to break out from that, say goodbye to it forever. After we say goodbye to the legacy solution, we can migrate into a better solution, into modern solution. What is definitely recommended in AWS, we have access to plenty of fully managed and purpose-built services. By fully managed services, we're meaning that all of that typical management that has to be done, that management is done by AWS. So for example, when we're using a fully managed relational database, all of this patching, updating, installing, securing, scaling, monitoring, etc., 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 all of that, which in the past we needed a team of database experts to perform. Nowadays, AWS can do it automatically for us. So recommended to use this fully managed, purpose-built solution. Maybe we don't want to get rid of our database whatsoever. Maybe we want to modernize the solution. Again, in AWS, we do have services that we can use. There's actually a dedicated service specifically created for data warehouses called Amazon Redshift. So with Redshift, we can create a petabyte scale data warehouse solution. In AWS, we can do it very quickly. We can use advanced analytical features, advanced machine learning, AI features. We can actually even use this data warehouse solution to combine data from other AWS services. So all of that is possible by using a slightly more modern data warehousing solution. So let's do that. Let's build a modern application using purpose-built data stores, using dedicated services, and most importantly, let's build the modern applications using data. So maybe you find yourself in an unlucky situation that you're kind of like locked in with like some vendor. Why you might want to consider actually getting out of the contract if that's possible. Just take a look at prices, take a look at how much you're paying. Some of these database technologies or data warehouse technologies are insanely expensive. So just take a look at how much you're paying. Think about if you actually do need to pay that much. Also, if you're using some of these technologies are proprietary solutions, so the possible migration at some point might be a little bit tricky. So essentially, you're locked in with a certain vendor. Also, the prices of licensing. I know one very popular database provider just announced, just a couple of months ago, announced a significant increase of licenses for the cloud. So probably that's not something that you want to do. So essentially, the idea behind it is if you find yourself in a situation that you're not very happy, perhaps you should consider migration to some of these open source databases. So we do have open source databases. Some of them are very popular. MySQL is very popular. PostgreSQL is very popular. MariaDB is very popular. So we have the open source databases, they're very good. I know what you're probably gonna say, yeah, open source databases are great, cost much less, etc., etc. But when it comes to the commercial support, what do we do? There's not really that much to do with commercial databases. Ladies and gentlemen, I actually have good news for you because there is. The solution that you might want to take a look at, it's called Amazon Aurora. So Amazon Aurora, it's actually an engine that's built by AWS. And the engine is compatible with the two most popular open source database solutions, so MySQL and PostgreSQL. This engine is very, very interesting because this engine will actually get you the most out of the two worlds. So when it comes to the open source world, which is all about saving as much as possible, is the open source world. So you're going to save you're gonna save a little bit of money. And then when it comes to the commercial grade databases, their performance and stability, security, durability, etc., you're going to get it as well. So now you essentially, for a price of an open source database, you're gonna have a fully featured, secured, durable, and scalable commercial grade databases. So something that's very, very interesting. AWS, by the way, did some benchmarks about the performance of running Amazon Aurora, either MySQL or Postgre, and then running just plain both MySQL and Postgre. And AWS find out that you can get about 3 to 5 times more performance than running just the plain open source version. So AWS did quite a lot of tweakings and updates, etc., to get you that commercial grade performance. And I can send you some case studies about some benchmarks. You're going to get about 3 to 5 times more performance than running the plain MySQL or Postgres. Just out of curiosity, this is probably the reason why Amazon Aurora is the fastest growing service in the history of AWS. AWS actually took a look at some data, and AWS found out that over 400,000 databases have already been migrated to AWS and have been migrated using a service which is called DMS. So DMS, it stands for Database Migration Service. This is a service that we can use to migrate our databases. So wherever your database might be right now, on-prem facility or different cloud provider, doesn't really matter. Wherever your database is, you can use DMS to migrate your database to AWS. And over 400,000 databases. Down here you can see a list of some of the customers that have used the service to migrate databases. So as you can see, there is a great support should you decide to run your data solution in AWS. By the way, maybe I should add that the database migration service can be used either for one-time database migration. So I just want to migrate everything as it's right now. I can also use database migration service for an ongoing replication. So essentially, the database migration service can also keep, both of these databases at sync. So if there are any changes in the primary database, all of these changes can be automatically replicated to the newly migrated database. So all of that is possible. And one more note about the service, we can actually use it together with another tool, which is called SCT, Schema Conversion Tool. And then Schema Conversion Tool is the tool that can help us to change the database engine. So perhaps if you're running, let's say, a very expensive Oracle database in the on-premise environment, and you do not want to pay these expensive licenses anymore, maybe you'll now be interested in this Amazon Aurora, as we've talked about. The SCT tool can help you change the schema, so change the database engine from, let's say, that expensive Oracle into Amazon Aurora. So all of that is possible. As we said, in AWS, we have over 17 purpose-built data solutions. So it's never a one-size-fit-all approach. Again, this is the approach that perhaps we used in the past. That the company has decided that everybody is going to be using a certain database and certain version of the database, and regardless what your actual workload was about, everybody had to use it. That idea, that ideology, that's the thing in the past. Now we recognize that every workflow is individual, and a different workflow would benefit from a different database technologies. For instance, we have some relational databases. We have Aurora or RDS, so services we've already talked about. So if you're running, let's say, an on-premise environment, some of these relational databases, very easy. You can use the tools that we've talked about to quickly and easily and safely migrate them to AWS. Of course, then we've got a whole suite of non-relational databases. Unfortunately, in this slide, we only had spaces for a few of them. So we've got a databases, a key value databases with a flexible schema. We've got graph databases for storing relationship. We've got a blockchain-based databases, so these like append-only databases, etc., etc., etc. We can find plenty non-relational databases in AWS. So again, if you run some of these popular non-relational databases currently, MongoDB, Cassandra, Redis, Memcached, etc., etc., you can again very quickly and easily migrate them to AWS. As I said, AWS can also help us to create a data warehousing solution. So I'm not saying that nobody should use data warehouses anymore. There are absolutely great use cases for data warehouses. But perhaps if you're thinking about using this technology, think about some of the more modern solution. In AWS, we've got a great service, Amazon Redshift, so we can run a data warehouse, any scale, any performance, for a really good price. So again, if you're running some of these data warehouses currently, potentially something we can consider for migration. So essentially, all of these technologies were about storing data in one form or another. Of course, we also have technologies for working with the data. For instance, we've got Amazon EMR. This is the technology that we can use to run our analytics. So whatever analytics we want to run, we've got to choose from plenty of platforms, technology like Spark, etc., Hadoop, etc. So we can use EMR for analytics. We can use Amazon OpenSearch service for operational analytics. So dig through the data, visualize data, search for relevant information. All of that is possible. For real-time analytics, we also have Amazon MSK. And then for creating machine learning application, using machine learning, using data, getting value from data, we have Amazon SageMaker. So as you can see, when it comes to AWS, we've got plenty of support, plenty of opportunities, plenty of different services we can choose from. The reason why we want to choose some of these services, because the services, the data and database services we've discussed are fully managed services. Essentially, by fully managed service, we're meaning that all of this that you can see on the slide, from hardware, monitoring, patching, clustering, scaling, security, I don't know, all of these different stuff that we can see here, now with these fully managed services will be done by AWS. So essentially, in the past, you needed a team of people to simply run your applications without even producing, any analytical outputs, any insights, just to run the things. You need a large teams of people just to do that. Now, should you choose to do it, all of this management can be done by AWS, and it's actually offered from these services. So should you use any of the database service we've discussed, we've seen on the previous slide, all of this that you can see on the slide will be done by AWS. So the idea is now you don't need to worry about this undifferentiated heavy lifting. There is nothing proprietary about installing some Linux updates. everybody does it the same. But what's important that now you have more time, more energy to focus on something that will actually make a difference. So now you can actually focus on bringing the best possible products and services to your customers. So I know AWS is not the only cloud provider out there, so obviously you have a choice to choose any cloud provider that you want. The reason why you might want to stick with AWS, it's the biggest one, so offers the most comprehensive set of products and services, proven operational experience, cloud provider that's been in a business for the longest, operates the largest fleets of servers, largest for the biggest number of customers, most secure, reliable. There's some case studies if you're interested, you can take a look at, and we will also talk about AWS being biggest one. So I don't want to make this the sales page. Obviously, if you're interested about all of these case studies, etc., let me know. I'll be super happy to share them with you. So one size fits solution doesn't work at all, right? We've already talked about it, that idea that we have like one service, one database, and we will use it for any possible solution. That's the thinking of the past. That's something that definitely doesn't work. What we have on the slide is the knowledge and experience from the first comers, so from the early cloud adopters, essentially, all the customers that are already in AWS, they're already utilizing all of these services. This is pretty much, what they found out. So this is the experience that they're happy to share with us. As you can see, the modern application, we're talking about millions of users. We're not talking about, hundreds or thousands. Now we're talking about terabytes, petabytes, potentially exabytes of information. So forget about megabytes and gigabytes anymore. Now we have much more information. We have a global customer that require great performance, great scale, great availability of our services. So we need a fault tolerance as well. We have all of these new emerging technologies, IoT devices, mobile devices, 5G networks, etc. Typically, we want to utilize the pay-as-you-go pricing. So nobody really likes the long commitment anymore, because it's very hard to make a commitment if you don't know, the future for sure. So how can you make a commitment about that? So pay-as-you-go pricing, that's certainly something that's interesting in. And obviously, we want to scale our infrastructure according to our customers' needs. So if there's a Black Friday and if we need to scale from 100,000 users to 10 million, we need to be able to do it ideally automatically and also as quickly as possible. We usually have only one shot. If you go on a website and it's not available, probably you're gonna go on a different one. So we need to be very, very quick. If we want to implement all of that, as we said, we have the most complete family of a purpose-built data services. I know we've already discussed some of them. So we have a whole suite of services for databases. So we've got 17 purpose-built databases. We've got a blockchain services, should we want to create our own application based on blockchain. We've got a whole suite of services for analytics, for analytical use cases. Of course, we also have several services for data lakes, building, managing, organizing, securing, etc. And lastly, this is a very, very interesting category, probably my favorite, is the suite of services that use business intelligence and machine learning. So essentially, all of these services that you can see up there in the top part are the services that are using AWS knowledge. AWS already trained, configured these services. So now we can use all of these cool AI services for things like image recognition, voice recognition, text recognition, etc., without absolutely any knowledge about even without even knowing what ML stands for. So we can simply use the service. We upload that image, text, video, whatever we want, and we'll have we'll get the response out of it. So much easier. We don't have to reinvent the wheel. We can take a use of what somebody's already created before. Okay, so that was the end of the first part, the modernization. Modernization as the key. Now let's talk about the second part. Let's talk about unifying part. So let's take a look at about how can we put all of our information together. As we said, the service will probably choose while building this data lake, while building this centralized repository that we can use to store any information in any format, is going to be Amazon S3. So Amazon S3 is the most secure, durable, and scalable storage service that we can use to build our data lake. Amazon S3 can store an unlimited number of objects. So it doesn't really matter if you have hundreds, thousands, or I don't know, billions of objects. S3 offers unlimited storage. So with S3, you've got unlimited storage. Of course, S3 has also been built to be the most durable storage service out there. S3 has actually built to provide 11 nines of durability. So 99.999, well, just put down 11 nines over there. If that's too hard to abstract for you to imagine, imagine this. 11 nines represents that if you stored 100,000 files in S3, on average, you can expect to lose a single one of these 100,000 files every 10 million years. So that's what S3 durability, that's what the 11 nines mean in a real life. Also, S3 has been built with security, compliance, and audit capabilities in mind. So we've got very granular control. By default, nobody has any access. We have to explicitly grant access to a specific file. We've got the fastest possible performance at the lowest cost. When it comes with cost, we actually have a different storage classes. So depending on our usage pattern, some objects that are accessed frequently can be put in a storage class for that. Some objects that are accessed less frequently, maybe some archive files, etc., can also be put in cheaper storage classes. So that's Amazon S3. Amazon S3 is typically used as the service for the storage of our data lake. So one more time, any data coming from anywhere, typically we want to store them in S3. When it comes to data movement, we recognize two different types of data movement. We can move inside out. So this is what we have represented on the slide. Imagine that you use S3 as the service that your applications, let's say, store log files directly. So this is that primary storage service. And then since we have data in S3, this is the primary storage service, we can now push the data to all of these operational databases and other data store. So we're moving inside out from that original store to additional services. However, what we're probably going to do most frequently is the other way around. So we're going to move outside in. So essentially, we're going to take data from all of these different places, all of these different databases, all of these different data store solutions, all of these analytical solutions, data warehouse solutions, etc., etc. And we're going to move all of this data to S3. So this is what we call outside in movement. Of course, we can also move data around different database services. So we also have the around the perimeter movement. If you want to move from one database to another, there is no need to use S3 as kind of like intermediary. We can simply do the migration directly between these two data sources. So when it comes to data lake in S3, as we said, we will typically use S3 as the storage service. So we've got S3 in here. There's also a great analytical service that's integrated with S3. It's called Amazon Athena. Amazon Athena will allow us to run our analytics directly on data in S3. So imagine you've got data in the text file, CSV file, Parquet files. You've got millions of these files, stored in different places in S3, and you want to run analytics using a SQL. You want to write a SQL query, select top 10 performing employees as an example. In the past, what you had to do, you actually had to transfer all of your data from the original files into databases, so build these ETL pipelines, and then after you had data in databases, you could run your analytics. With Amazon Athena, that's not the case anymore. You can actually run analytics directly on your data, so no need to extract any information from all of these files. You can leave the data as files over there, and Athena will allow you to run the analytics. Also, we've got the AWS Lake Formation here. So AWS Lake Formation is the service that we can use to create a data lake. Of course, you can configure all of these different services individually, configure all the permissions individually, but it is going to take you quite a while. There's no need to do that. You can use Amazon Data Lake to centrally create data lake, configure security, permissions, all of it from one space. So in a matter of few hours, you can have a pretty robust enterprise-grade data lake, enterprise-grade data lake in AWS. For any kind of data transformation, there's a service called AWS Glue. So AWS Glue will then be used in the background as the service for transforming data from different formats, etc. So a couple of these purpose-built data services. I've already mentioned Amazon Athena, which is the interactive query service, so you can run your SQL query directly on data stored across millions of different files in S3. If you want to do any kind of big data processing, you want to run some of these very popular frameworks like Spark, Hadoop, Presto, etc. You can use Amazon EMR. So this is for big data processing, big data analytics. For logs and search analytics, also visualization, we can do Amazon Elasticsearch. So we've got Elasticsearch. For real-time analytics, for streaming information, imagine you have data from some of these sensors like thermostats that produces temperature measurement every second. You've got millions of them, or maybe on a company floor, you've got all of these different sensors. So you're going to have a large volume of streaming information. So we've got Amazon Kinesis family for that. So that's to deal with streaming information, and Amazon MSK for analytics. And last but not least, I've already mentioned Amazon Redshift as the AWS data warehousing solution. So maybe a little bit more about the Amazon Redshift. Amazon Redshift will provide you fast performance, any scale. Again, AWS claims it's up to 3 times faster than any other cloud data warehousing solution. So if you choose to use Amazon Redshift, you can utilize all of this great performance at a significantly less cost that you can find elsewhere. Also, Amazon Redshift has been integrated with plenty of advanced analytical features. So if you want to run a very advanced analytics, you can do that as well. There are also some machine learning and AI features. Essentially, AWS is constantly trying to make your life as easier as possible. So if there is an opportunity for any sort of optimization that could make things faster, or even some very advanced AI optimization that could draw some insights that you perhaps didn't know before, you can find it there. And if we were to talk about money, again, you can find Redshift being about half cheaper than any other data warehouse solution. So with the Redshift, essentially, you're going to get the best possible price performance ratio that's out there in the world nowadays. If you're curious how is actually AWS able to achieve that, there are a couple of factors. First one, AWS designed their own proprietary hardware. Maybe you've heard about the AWS chips, the Nitro-based chips, which are super, super fast if you do the benchmark with like traditional like Intel-based chips. Of course, also AWS, it's running a super fast network. So we've got a fully redundant 100 gig, not meg, but 100 gig per second network. We've already talked about the advanced ML and AI functionalities that will, for example, automatically reorganize data in the data warehouse so you can run your analytics much, much faster. And also the last thing, which is actually something that I personally really like, you can actually very easily integrate data in your data warehouse, Redshift, with all other data that you have in all other databases, potentially in S3. And you can actually run analytics on the data without needing to move the data, which is absolutely fantastic. So essentially, if you have data in 5 different databases and in S3, now directly from the data warehouse, from your Redshift cluster, you can run all of your analytics and you can use the data as if they were already included in your data warehouse. So something that's super cool and super interesting. So essentially, this is what we find ourselves with. So we've got our various data stores. We're going to build a data pipeline, and we're going to transfer data into the target location. These data stores, these were our original silos. It can be any databases, any systems, you know, any places that or any technology that produces data. We've got we then build the ETL pipeline, and then we're going to store the data in the target store solution, most likely our S3 bucket. So how are we going to do that? The core component of any data pipeline is going to be the ETL. So ETL, it stands for extract, transform, and load. Essentially, the ETL are technologies that we can use to get information from one place, do whatever kind of modification we need with the information, transforming, changing format, deleting something, etc., and then storing information elsewhere. We can do all of that in a code, that's absolutely fine, or we can actually use several visualization tools to do all of these stuff visually. So this is really cool. You don't need to learn, you know, very complicated Python code or something like that. You can do all of these different transformation visually. All the data will be then replicated. As we said, we're not saying to, you know, get rid of all the databases, get rid of data warehouse, use only data lake. It is not required. Some workloads, you know, would be better off in a traditional databases or perhaps a data warehouse. But since we have the connectivity, we can very easily use the data, you know, in all of the different places. The feature that we can use, you know, to query data between different places, it's called federated query. So that's something I've already mentioned when I was talking about Redshift, the ability to query data, you know, in various databases. This is the name of the feature. It's called federated query. So to continue this this idea of, you know, breaking data silos and extracting the information, there's also another tool that we can use in Redshift, which is called here we've got it, Redshift Spectrum. So with a Redshift Spectrum, it will enable us to query the data that's stored in S3, that's stored in various formats. So we've already talked about this idea of, saving data in data lake, doing this as quickly as possible, probably in the original format. So we might have data in all different kind of formats: Parquet, OCR, Arbor, CSV, etc., etc. Fortunately, with a Redshift Spectrum, we can run analytics, we can query the information without any kind of movement needed. So just leave the files as they are stored in S3. With the Redshift Spectrum, we can directly query information at any scale, any number of files, without moving any data. So another benefit of Redshift that we are going to take a use is the ability to do this querying, do this analytics as quickly as possible. That speed, how quickly it is going to be done, will depend on a data format. So if we're using something like a text file format, like text file, CSV, etc., it is going to be a little bit slow. However, if we're using very popular open source Apache Parquet format, so it's the open data format, this format is actually supported by AWS Analytical Services, and we're going to get exactly the same query much faster. So definitely a good idea to use Parquet. A Redshift is fully compatible to reading Parquet file. Also, we can export the results in a Parquet format as well. Another thing, a really cool feature, and we've already talked about this idea before, it's this federated query. So federated query would allow us to connect to any database service that's in AWS. So if you have data sitting around across different AWS services, and you want to run a query that's going to use data from all of these different individual solutions, we can use federated query in either Amazon Redshift or Athena. And the federated query functionality would allow us to run a query on all of these individual data sources, just if all the data were placed in a single place. We can actually also connect not only databases in AWS, but if you also have some databases on-prem, it's also absolutely possible. So federated query can also query the data that you have in on-premise databases, or maybe in a different cloud provider as well. Another thing that, or the last thing from this module, from this blog, is a really cool feature of AWS Glue service. So AWS Glue service, this is our ETL service. So the Glue service is a service that we can use to transform data from whatever format, from whatever place, into whatever format, and store them whenever we want. So this is that ETL service, the service that we can use for actual migration and transformation of the data. With Glue, we can create something which is called elastic views. So these elastic views are essentially a virtual table. They're materialized views. And these materialized views will help us to connect to various data sources. So here we've connected to various data sources. And what will Glue actually do? Glue will do the initial data migration to whenever we want, so that's fine. But Glue will also keep an eye on the original places, and should there be any change in the original place, Glue will replicate the change across to the target location. So it's essentially like keeping an eye out on all of these original data silos on these databases. If there is something new, if there's something happening over there, the Glue will automatically replicate it to the target location. Okay, so we've got all of these great services. They're fantastic. There are also plenty other services, plenty other feature we unfortunately haven't had time to discuss. But even from all what we've talked about, using all of these services, it's really good. But we should probably not even think about using any of these services unless we figure out how to implement security and governance. So how do we ensure that only right people, only right application have the access to the data and nobody else? So unified governance, probably the most important aspects in building any sort of data solution. Obviously, if you're feeling confident, we can configure all of the governance individually using, individual services in all of these different places. But as you can see, it's probably not the best way to do it. Fortunately, AWS, will come to help us in this, and the service that we can use to build a unified governance are the governance that will be applicable, across our entire data lake solution. It's called Lake Formation. I know I've already mentioned the name of the service before. So Lake Formation, this is the service that we can use to build our entire data lake. So if you have nothing right now, but you like this idea of having a data lake and you want to build it, and you don't want to do it manually, configuring all of these different services like S3, Glue, etc., all of these different services we've talked about. You don't have to worry about it. You don't have to simply open up a lake formation, and in a few hours, you'll probably find yourself with fully built data lake solution in AWS. Using lake formation, you can centrally define security, governance, audit, and any other requirements that you have. So you can rest assured, that all of your data is secure. So all of your developer, analyst, scientists can access information, analyze information, but they can only access, analyze, and work with data that they have been provided access. So with lake formation, we can create policies that will be enforced across our entire data lake solution. So the lake formation will be integrated with all the security services, storage services, analytical machine learning, etc. And we will be centrally enforcing the governments that we've defined. One of the really nice features of lake formation is the ability to define permission based on the table, columns, and databases. So essentially, imagine that we have a S3. In S3, we've got individual files. It can be, let's say, log files. How do we manage permissions in S3? We manage permission per object level. So let's say this log file will be accessible to someone. This log file can be accessible to someone else. The problem with this approach is that inside a single log file, we might have multiple information, and maybe you actually want more granularity. Maybe you only want a certain rows from a file to be accessible by someone, or certain columns from the file to be accessible by someone. So using a lake formation, we can do absolutely that. If you're curious which cloud provider is running the most data lakes, well, here we've got some of the companies that trust AWS to run their data lake solutions. So let's move on and let's take a look at the last component for our modern data strategy, which was innovation. Essentially, when it comes to support of AWS, whatever level you need AWS to be, that kind of support you're going to get. For instance, for expert practitioner, if you're an expert developer, if you need to access directly the major machine learning frameworks, so if terms like TensorFlow, PyTorch, MXNet, and some others, if it makes sense to you, of course, you can access these machine learning frameworks directly. For data scientists and machine learning developers, You do not need to work with the frameworks directly, but you can actually work with in a higher level of abstraction. So you can work with the machine learning service, which is called SageMaker. So SageMaker, this is the machine learning service that AWS created to make machine learning as easy to use as possible. So all of the data scientists, machine learning developers can access the service directly. Then for everybody else, for all of the business users, all the developers, anybody else that needs to access, needs to utilize all of these technologies to actually get some insights, but doesn't necessarily know anything about programming, any of these technologies we've discussed, we've got plenty of AI services. So all the business user, all the developers, without any ML knowledge required, without any AI knowledge required, we can directly access services. As we said, there is a whole fleet of services to work with text, video, audio, creating chatbots, services for business tools like personalization services, data center services, contact center services, search services, developing services, healthcare services, industrial services, etc. So all of these are examples of AWS AI services that anybody can access. So without any ML knowledge required, we can use these services to get some information out of our data. So essentially, today business problems can be solved by machine learning. The machine learning technologies offer us ability to discover things that we didn't even think were possible before. Here we've got some examples. For instance, we can use Amazon personalization to personalize our customer experience. We can use Amazon fraud detector to detect fraudulent transactions, etc., etc. So again, we've got all of these services. We can use them to uncover the opportunities that we didn't think were even available before. Of course, we can use all of these ML services for industrial processes as well. So if you run a factory, if you have a facility and you need to improve the processes inside, there's again a whole suite of services. For instance, we've got Amazon Monitoring, which is an end-to-end solution for equipment monitoring. We've got Amazon Lookup, which is the solution for equipment that do already have sensors, so we can just improve the information that we get from these equipment. We've got a lookup for vision, which is to spot any products with defects. So obviously, if you have a factory, you want to uncover as much potential defects as possible. So we've got lookup for vision. We've got AWS Panorama SDK and Panorama Appliance. This is to improve the camera experience. So if you have a camera and you need to improve the recognition that you get by using a very sophisticated compute vision models, again, AWS has got you covered. So there are plenty of different services for plenty of industries. So depending which industry you are, I strongly encourage you to check AWS website, look for that industry you're in, and you will be able to find what AWS has got to offer specific to your industry. If you're in health industry, healthcare industry, there is an Amazon Health Lake. So this is the data lake that is used to collect all the medical information. This data lake has been pre-created to help you, work with the medical information. So it organizes the data in chronological order, so you can look at trends like disease progressions over time, giving the healthcare specialist a new way how to look at all of these information that's already available. Of course, it's a medical information, so it's a highly regulated information. So the solution has been built using all of the applicable laws and regulatory standards in mind. So machine learning can be a very complex, very complicated process. Go ahead and ask any of the machine learning expert what is actually required, to go from a data that's, in some initial system that's stored in an initial database, all the way up to a meaningful insight that we get by extracting info, enhancing, etc., etc. So in here, what we can see is the whole machine learning pipeline. So this is what people spend days, weeks, months to actually get information out of it. The great news is that, as we said, AWS is trying to automate as much solution as possible. Fortunately, we do have access to the Amazon SageMaker service. So SageMaker is the service that we can use to build, train, and deploy machine learning model as quickly as possible. So essentially, we don't need to spend, or the machine learning experts do not need to spend that much time, working with information, working with machine learning models, deploying, training, testing, building, etc. All of that, it's already done in the service. So this is the service that's been created to make machine learning as accessible as possible. So AWS also brings this machine learning capability closer to your data. For instance, there are some AWS database services that already have a machine learning capabilities. For example, we've already talked about Amazon Aurora. So if you use Amazon Aurora, you can actually use a machine learning with a simple SQL statement to run a very complex machine learning model. So if you're using Amazon Aurora, only thing you have to write a very simple SQL expression, and you do not need to worry about all of that that's done in the background. All of this tuning, testing, building models, all of that will be done automatically. You just write it, very simple SQL. The same, by the way, for Amazon Neptune, which is the graph database, and other. The data warehouse and data lake solution. So both Amazon Redshift that we've discussed, the data warehouse solution, has the native machine learning features. Amazon Athena, which is that interactive query service, again has the machine learning capabilities. And last one, if you're using a business intelligence tool, so business intelligence, it's about visualizing the information and being able to display everything in a very nice format. Obviously, looking at a very nice graph charts, it's always much nicer than just digging through so much data. So we can visualize an information. And again, in an AWS BI solution, which is called QuickSight, we again have the machine learning features as well. So, ladies and gentlemen, that's essentially all what I wanted to talk about. So hopefully now you know a little bit more about what AWS has got to offer when it comes to working with data. Hopefully it also encouraged you a little bit to maybe modernize the solution, whatever you have. If you're not already in a cloud, well, start thinking about migrating to cloud. Or if you've already running some workload in the cloud, maybe start thinking about how you can use some of the information, some of the data that you have to make things better, to create better products, to create better services for your customers. So as the next step, what I would suggest, if you want to continue with the education, definitely official AWS training portal. It's called Skill Builder. So just go just go to Skill Builder. This is official AWS training portal with 500+ free courses. So if you want to find out anything, if you want to take any AWS training, definitely do that. There is also on this Skill Builder portal, you will find the Data Analytics Fundamental course. It's a free course. So if you're interested in data analytics, definitely take this free course and you can find more information. If you like classroom trainings with a live instructor, like me like we did today. There's also the classroom training. You can do it online, by the way, don't worry. You don't have to come to the physical classroom, which is called Big Data on AWS. You've probably also heard about certifications. So AWS offers certifications in the different levels, different areas. So if that's something you should be interested in, I strongly encourage you to do that. So definitely take a look at a certification website. And one last thing, there are also these ramp up guides. So this ramp up guide is essentially a curated list of courses from AWS. So if you want to take, if you have a little bit of time for the educations, but you don't know which of these, 500 plus courses to take and which order, you can take a look at this curated list, a ramp up guide for data analytics, and you can find this handpicked selection of courses. Also, if you want to take the certification and if you want to practice for free, if you want to try it out and see if you'll be able to pass it, or maybe if you need a little bit more studying, you can actually take a free exam readiness class. It's all online, so just go on AWS website and you can find all of this information. So, ladies and gentlemen, that's actually it. That's all I wanted to say. I'm really hoping that you've enjoyed today's webinar. I posted a link for the final evaluation. So if you do have a couple minutes to fill out the final evaluation, that would be absolutely fantastic. So one more time, my name is Tomas. One more time, should anybody wishes to connect and stay in touch, there's a link to my LinkedIn profile. And I'm simply just going to say thank you so much for your attention. Hopefully you've enjoyed it. There are also other webinars today, so if you want, you can actually sign up as part of the AWS Discovery Day. You can find a little bit more about AWS World. So hopefully see you all in some other webinars. So thank you so much. Good luck and take care.